Operating systems are not built to keep secrets. They are engineered to prioritize performance, structural efficiency, and rapid crash recovery over data sanitization. Because of this specific architecture, the Windows operating system functions as an indelible diary, systematically logging hardware configurations, file modifications, and user behaviors. This is the physical foundation where data is permanently etched. Look closely at the shiny Platter and the read-write head assembly of this hard drive. The operating system does not read raw metal and magnetism directly. Instead, it constructs a complex logical map, a file system, to organize and navigate the physical space. We are going to deconstruct the Microsoft file system architecture to locate the digital leftovers that map a user's exact footprint. Understanding exactly how Windows logically allocates physical space is the mandatory first step to finding hidden forensic data. A disk partition is geometrically divided into physical sectors, typically 512 bytes each, which are grouped into logical clusters. When a file is saved, the OS assigns it to a specific sequence of cluster addresses. These 3.5-inch floppy disks represent the era of the File Allocation Table, or FAT. FAT was Microsoft's original, simple map designed to point the OS to the correct clusters on early media formats. As storage hardware expanded, the original FAT system evolved into FAT32 and eventually exFAT to handle massive modern partition sizes and larger individual file limits. While FAT variants are still common on external flash drives, modern Windows operating environments rely almost entirely on NTFS, or New Technology File System. The Master File Table, or MFT, functions as a central relational database, storing exact file metadata, access rights, and precise timestamps linking directly to the cluster grid. Because modern file systems like NTFS operate as relational databases, they permanently index the complete chronological history of a file's existence. When a user highlights a document and presses Delete in File Explorer or executes an MS-DOS command, they assume the data is completely erased. In this hexadecimal view, the OS replaces the file name's first character with the hex value 0E5. This marks the cluster as unallocated. The logical space is freed, but the actual file data remains completely intact on the physical disk until overwritten. Even actively saved files leave traces. Files rarely fill their assigned clusters perfectly. The unused physical space remaining between the end of a file's actual data and the end of its assigned cluster is known as drive slack space. In a 4 kilobyte cluster holding a 2 kilobyte file, the void splits. File slack is the empty space. RAM slack is data parted by the OS from active memory, permanently trapping volatile data like passwords and email fragments never explicitly saved to the drive. Hitting the delete key actually creates 2 separate evidentiary targets for an investigator: the primary unallocated data waiting to be overwritten, and the residual artifacts locked away in the slack space. Beyond user files, the NTFS master file table generates hidden system files dedicated entirely to active data management and tracking. The Update Sequence Number Journal, or USIN journal, operates as a persistent, low-level log of actions performed across the entire volume. It chronologically records exactly when data is added to a file, when an item is moved across directories, or when a user renames a document. Windows utilizes Prefetch files. Their functional purpose is optimization, preloading links and executable data into the computer's memory to drastically speed up application launch times. To achieve that execution speed, the operating system is forced to record exactly how, when, and where those applications are utilized. This timeline visualizes the metadata extracted directly from a single Prefetch file. We can extract the exact installation date of the executable, the precise number of times it was run, and the secondary files it accessed. Hidden telemetry logs like the USN journal and Prefetch allow an investigator to establish deliberate user intent and systematic activity. The highest OS behavioral tracking occurs in the Windows Registry, a massive hierarchical database controlling hardware, software, and user preferences. By navigating specific keys and subkeys, an examiner locates precise trace evidence, like the exact identity of the last logged-on user. Alongside the registry, Windows relies on massive standalone system files dedicated strictly to volatile memory management. The pagefile.sys functions as a physical extension of the system's RAM, utilizing hard drive space to swap data in and out to maintain performance when physical memory is full. Then there is the hiberfile.sys, a massive file generated by a very specific user action, placing the computer into hibernation mode. To preserve the active session, Windows takes the highly volatile state of the RAM and dumps it onto the hard drive into this storage block. Because this file is effectively frozen RAM, extracting its contents requires specialized memory analysis techniques rather than standard file carving. Through the registry, page files, and hibernation dumps, the operating system's built-in optimization tools inadvertently capture the complete, frozen state of both the machine and the user's workflow at an exact moment in time. Watch how a user session maps across the architecture. A user logs in and opens a browser. Instantly, a registry subkey records the login, and a prefetch file logs the launch. Next, the user downloads and attempts to delete a file. A cluster is allocated, an MFT record generated, and upon deletion, the OS shifts the hexadecimal flag to 0xE5. Finally, the user closes the laptop. The active RAM state is written to the hiberfile.sys block, freezing the session data. True digital forensics relies on corroborating these independent architectural layers. A suspect might clear their browser history, but they cannot bypass the USN journal or wipe the drive slack space without specialized tools. To a trained analyst, the system's relentless drive for structural efficiency and recovery permanently exposes a user's hidden digital life.